All right, here I have AB, that's a line segment. We call that congruent. It's congruent to line segment CD. So the way I would type that out, I'd say line segment AB is congruent to line segment CD. What does that picture look like? Notice none of these share the same letters. So when I draw this, I'm just going to make two lines, maybe, oops, still on the box. Change that to a line. I'm going to make one like maybe right there. And then it doesn't have to be the same direction, but should be the same length. To show that they're the same, you put a little line through it. That means that they're the same. And then I would label it, put some endpoints on there. I'll let that be A, and that be B, and I'll let that be C. I'll let that be D. So I call that A, B, C, D. I know my alphabet. Oh, that's a D. I don't know my alphabet. Okay. Now this one, you should know that this symbol right here, if they are the same, and you're talking about lines or line segments, that means what we call parallel. So what I have is I'm going to say that line segment JK, is parallel to line segment LM. That's all that means. Now the way I would write that, I'm probably going to draw this by hand. I would say J, K, and LM. And then to show that they're parallel, if you use this symbol straight up and down, and it might actually look nicer if I use the text box. And it's the one that looks like this. So that means parallel. So that's what I would call parallel. It's also good to put a thing on here to say that it's a line segment, over here to say that's a line segment. So the way I would read that is JK is parallel to LM. Remember, a perpendicular looks like that. We can skip 9. Number 10. We got XZ, we got XY, we got YZ. X, Y, and Z are collinear points. Y is between X and Z. So that's key. I'm going to plot X. I'll put X right there. And I'll put Z right there. I'll label those. So there's X. There's Z. And the key here is they say that Y is between. So when I'm plotting this point, if I put Y right there, that is not between. To be between means it's somewhere on that linear path. So it might help to draw the line from X to Z so that I could then take this point, and it doesn't want me to drag it, don't know why. There we go. And I could put it somewhere on that line, that means between. I'll put it right there, and we'll call that Y. All right, so what we know that XZ is 50. Okay, which usually it lets me paste. XZ is 50. There we go. So that'd be the whole thing. The whole thing is 50. We also know that XY is 2X. So this part right here is 2X. So we got 2X. YZ is 8X plus 10. So this part is 8x plus 10. So we got the whole thing is 50, and we got this piece is 2x, and then from here to here is 8x plus 10. How do I put all that together? Well, we're going to use something called the segment addition postulate that says if you take xy plus your yz, that equals the whole thing, xz. So filling this in, what is xy? Xy is 2x. What is yz? That's 8x plus 10. And that equals the whole thing, which is 50. So I'm going to solve this. I'm going to borrow some space. I'm going to make this actually smaller. I need more room to work with. I got tons of space. Look at that. And I'm going to solve this. First thing I would do is I would take 2x and 8x, add those together because they're like terms. And that's actually what we call 10x. So this two together is 10x. And I could bring down the rest. So that's plus 10 equals 50. Now from there, what I would do is I would get rid of the 10 because 10 and 50, we're trying to get x by itself. So I would subtract 10 from both sides. Subtract 10. Those go away. Bye-bye. And I would get 10x equals now 40. 10x comes down, 50 minus 10 is 40. And then from there, I would divide both sides by 10. Those go away. 40 divided by 10, you get 4. I just got x's forward. Did they ask me for x? Let's go see. Solve for x, okay. So for this part of the question, I got x is 4. I got that part now. But now they want me to find xy. They want me to find the distance xy, find the distance from x to y. Look, we have an equation for that. It says if you take 2 times x, that equals xy. Well, what is x? X is 4. What's 2 times 4? That's 8. So I also need to say that xy equals 8 because 2 times 4 is 8.